How's it going, YouTube? What's poppin'? I'm back with another math video. It's been a it's been a while, but I'm still at it, and I wanted to share. Here, let me get my notes. I wanted to share a cool pattern with powers of two. That I wanted to share that with you. So let's get started. Okay. So ultimately, ooh, I'm moving around the capture window. Okay. So I'm more of a blue man. I'm more like the color blue myself, so I'm gonna change it. Okay. So the end of this is actually a formula for sum from 2 to the a plus 1 to 2 to the b. And it's not really like the formula that it's like I wanted to highlight, more so this pattern to get to this formula, because at the end of the day, we have the formula for summing numbers a to b, which is more general, but I thought it was neat, so I wanted to share it with you. Let's get started. So let me start by writing out some numbers here. That's a wonky 2. This is a 2. Okay. And I'm going to express them as um, powers of 2. Okay. So this is 2 to the 0. This is equal to 2 to the 1. Okay. So this is 2 squared minus 1. This is 2 squared minus 0. Okay. And actually, I'm going to write this equivalently. This is 2 to the 1 minus 1, and 2 to the 1 minus 0. So maybe you're already kind of starting to see something going on here with these 1s and 0s. But let's keep going. So we got 5, and writing it as the next highest power, like, because 2 to the second is 4, so that's too low. So we'd have to go up 1. So 2 to the third, that's 4, 8. And so that'd be 8 minus 3. Okay, cool. So then, um, not that, sorry. 2, this would be 2 to the third minus 2. This is equal to 2 to the third minus 1. Maybe I can sneak a 9 in here. 9 is equal to 2 to the third. Wait, this is not right. 5, 2 times 2 is 4, 4 times 2 is 8, 8, 7, 6, 5, 8, 7, 6. Ooh, I'm missing the 7. I was gonna say, should be a 0 right here. Caught a little mistake. Okay, 7. It's getting kind of clustered. 2 to the third minus 1. And this is not necessary right now. Okay, so here, just observing the powers going from 1 to 0, we can see there's two numbers here, like 1, 0. There's two of them, so two numbers, which is equal to 2 to the 1. Okay, same here. Sorry, I should have two numbers. Okay, and for this starting from 2 to 3, we have four numbers. So we have 0, 3, sorry, 3, 2, 1, 0. So that's four numbers, and that's equal to 2 to the second. And starting at 9, I don't have to write them all out for you guys, but starting at 9, that's equal to 2 to the fourth minus, let me see, minus 7. Okay. And this continues to 2 to the fourth minus 0. which is 32. Oh, I'm sorry. This should be. Am I getting this right? We referred. I know. 2 to the 4 minus 0. Yeah, that's okay. 16. Okay. Cool. So that's 2 to the 4 minus 0. And this clump from 7 to 0, that has 8 numbers. Okay. Ah, 8 nums equals 2 to the 3. Ooh, 4 nums not equal 2. That should be a 2 to the second. So the pattern I'm trying to basically highlight here is each clump, each subsequent clump has like goes up a power of numbers. So like that difference counts down from like the number to 0, 2 to a power times. So using that, I'm gonna write a little lemma bean, freaking 2 to the n minus 1 plus 1. I hope this is legible. 2 to the n, that looks like an h. 2 to the n plus 1 until 2 to the n, 2 to the n minus 1 plus 1 to 2 to the n has 2 to the n minus 1 nums between it. Okay, and to be honest, I don't really have a proof for you regarding this. I just have been like balling and using my intuition for this, and I'm like, I went I went up to 64 and it held, so I'm just like, we ball, let's go with it. No, but I think I should like go back and write a little proof for that. But anyway, moving on, I'm gonna use this little fact in expressing it as a sum. So this is like kind of part two. Um, express um, as a sum. You'll see what I mean. So if I write like 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus whatever, like so on, um, like this, just gonna write dot dot dot. If I keep doing that, if we take here, okay, so for a tangible thing, let me start with 2 to the 4. So 2 to the 4 example, okay, 2 to the 4th. Um, so basically 2 to the 4 by the lemma has 2 to the 3 numbers ranging from 0 to 2, uh, ranging from 0 to 2 to the third minus 3. No, minus 3. Sorry, minus 1. 2 to the 3 minus 1. Okay, cool. Okay, so we can express those, like I showed earlier, like from 9 to 16, as 2 to the 4 minus 7 plus 2 to the 4 minus 6 plus 2 to the 4 minus 5 plus 2 to the 4 minus 4 plus 2 to the 4 minus 3 plus 2 to the 4 minus 2 plus 2 to the 4 minus 1, and then let me sneak it in here, plus 2 to the 4 minus 0, and that's going to give us 16. Okay, so cool, and now I'm going to just group all these up. So by the lemma, we have 2 to the 3 numbers, so that would mean if I group up all the 2 to the 4s, where's my freaking cursor? There it is. Jeez. Okay. If I group up all the 2 to the 4s, then we're going to have 2 to the 3 of them. Like, see, 1, 2, 3, 4, 5, 6, 7, 8 2 to the 4s, and that's 2 to the third. So we have 2 to the third, 2 to the 4s. Okay, cool. And then I'm going to group up all the, um, I'm going to group up all of the constants, or they're all constants, excuse me, all of the numbers, like 7, 6, 5, not the powers of 2. So then I'll get 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0. Not that I need the 0, but okay. Cool. And then that's just the sum from 1 to 7. So 2 to the 4 times 2 to the third minus a sum from um, 1 to 7. I'll try it like that. Maybe I should be clear. I equals 1 to 7. Cool. That's freaking lit. I don't know if people still say lit, but that's freaking lit. um, so yeah, okay. And now we're gonna use this fact. Let me see if I can extend my paint canvas, my Microsoft Paint canvas. Okay, fire. Cool. Okay. So now, part 3. In general. And this is, I think, where the fun part of math is kind of when you get to generalize something. I don't know, at least for me. But anyway, so to generalize it, the sum, and this is the grand finale, the sum from I equals 2 to the n minus 1, my n's still look like h's, 2 to the n minus 1 plus 1 to 2 to the n, this sum is equal to 2 to the n times 2 to the n 2 to the n minus 1 2 to the n minus 1 plus, and we factored out all those negatives, or you could say minus, I suppose, but maybe I will for clarity, but times the sum I equals 0, because we went to 0, 2, and then by the lemma, excuse me, all of those numbers, Cool. And if we do the algebra, this is equal to 2 to the n times 2 to the n minus 1. I'll keep it like a plus, I guess. Okay. And actually, no, I'm gonna expand, or I'm gonna write the closed formula for this sum. So this is actually, uh, okay. So, okay, I'm back. So I wrote, it's very hard to read, but I had to fit it in. So it's 2 to the n minus 1 minus 1, this this number here, and then 2 to the n minus 1 minus 1, again that same number, plus 1 um, over 2. And this is just expanding that, n plus 1 over 2, that formula there, where this is n. Okay, and if we continue, and I'm just gonna like write the final version here. If we keep going with the algebra, you will end up with the final formula of, like, if you simplify it, that's what I mean. You get 2 to the n I equals 2 to the n minus 1 plus 1, and this is I. This is equal to 2 to the n minus 1. Oh, nope, that is wrong. It is equal to 2 to the n, 2n minus 1 minus 2 to the 2n minus 3 plus 2 to the n minus 2. Okay, and that is the final formula. Let me get it all circled here. That is the formula I wanted to share with you today. Let me go back up. So yeah, that is the formula for sum from 2a plus 1 to 2b using this little pattern we found. Maybe I'll make another video showing the lemma, but I don't know. But yeah, this is the formula. I'm happy I got to share this with you, and I hope you enjoyed this math banger. Thanks. Bye.